So we are Webb Robotics Team 1466, and this is our robot design presentation. I'm Richard, and I'll talk about our goals for this season. So one of our first goals was that we wanted this robot to be very similar to our previous 2020 robot. But whenever we went to kick off and saw the skills challenges, we realized that we would have to make some changes. For instance, we wanted the robot to be faster for the time component of the challenges, and we wanted the robot to be more compact so it was easier to maneuver through the obstacles of the teleop and autonomous paths. And then at kickoff, we ranked each of the challenges by priority and similarity to try and see which three we wanted to really optimize towards. But then we later decided that we wanted to just try all the challenges so we'd get that educational purposes from it. And now Reed will talk about the drivetrain.
All right, okay. So our drivetrain, we decided to optimize it for the driving and the autonomous challenges. We wanted it to be very maneuverable. We wanted it to have a high top speed and fast acceleration. And we also, like Richard's mentioned before, we wanted it to be able to move easily through all the obstacles and be kind of lightweight as well. So what we did is we made it significantly smaller than we had ever built one before. The drivetrain is about 21 inches by 21 inches. And this led to all sorts of very cool, but we also had to make some very innovative decisions to get all the controls and the mechanisms to fit. As for the style of drivetrain, we wanted an omni-drive because we wanted it to be able to move laterally without turning in order to optimize those driving paths that we had for the challenges. And we debated between H drive and X drive. And we did this by a whiteboard. And we listed all the pros and cons of each. And we eventually settled for H drive. However, due to time and space constraints, getting the center wheel that's required for an H drive, it didn't really work out. So what happened was we still had too much lateral drift from the Omni wheels that made it very hard to control, especially for autonomous. So we ended up switching to traction wheels entirely. However, we still maintain very high maneuverability and we cannot drift sideways. So Catherine will talk about the sliding intake.
Yeah, so our intake went through a ton of design changes, and I'm really proud of where our final design is. We began with a passive forearm prototype that we made out of cardboard, but it was still fully functional, which was really cool to see. And it would use the momentum of the robot to push the intake out so that it could take balls in. We changed that to an active forearm intake because the passive was just unreliable and we just couldn't control it. And so with the active one, we attached a motor to a hinge that would open up the intake so that we could get balls in. We did enjoy this, but we just wanted a more streamlined process. And so we ended up switching to a spring latch system. But this was also really, really hard to maintain and really hard to get a good control over. So we decided to go with an active drawer slide system where we have a track placed on top of the intake and then a motor that gets in between the tracks and spins, pushing out the intake. This is a really efficient and a really cool system, and I'm really happy with how it works and looks on the robot. And Soumya will now talk about our roller.
So yeah, one aspect of the robot we wanted to have was a fluid system with the intake and shooter. And a key aspect to make this happen was the intake roller. So at first we started with a foam roller, but we had challenges to tame this fluid system. The foam roller would make the ball get stuck in different places and not go directly diagonal into the shooter. So it wasn't efficient at all. So then we decided to change this with vectored intake wheels, which had wheels on the actual intake roller that were in the direction towards the shooter. So this made the intake obtain the ball in any position to go directly into the shooter. So it made the system very efficient. This is what we wanted to have in the robot. And now Dimitri will talk about the shooter.
So when it comes to the shooter, there were not as many design changes, but still the design changes that we did do are very notable. So we started with the pre-ordered shooter we got, and we assembled it via the CAD model. But the only discrepancy is that we use one Falcon motor instead of two. From initial testing, we decided that regearing was needed so to get the balls to actually shoot as far as we wanted them to go. So we ended up just switching the top gear and the bottom gear on the shooter assembly, which ended up working a lot better. For making the thing that would help the balls go from the roller up into the shooter, we decided to go with the corrugated plastic prototype that was not as rigid as our final design, to help with dealing with the not so good to deal with balls that we had to use. And so our final was a Lexan one that we used, and both the centered compact design and its good integration with the battery help reinforce the compact design of the entire bot. And now Emery will talk about the electrical board.
So it took us a while to figure out exactly where the electronics board would go because our robot is so small and compact compared to what we're used to. So we thought about putting it places like the side of the shooter or above the robot or below it. And the most reliable place was with the most room was the bottom of the robot, but it was difficult to reach because of the shooter and all of the things. So we decided to make a hinged system, so we can turn up the robot on its side and open up the hinges to access the board. So it's a rod with hinges on it, just connected to a piece of Lexan. And this works really well because it's out of the way and it makes the robot look very smooth on the outside. And it also took us a while to figure out exactly how to keep the board on the bottom of the robot. So at first we just had zip ties, but that wasn't permanent enough. So we tried a latch system with pins, and that's much more reliable, and we still have it and it works really well. So yeah, that's all. Thank you.